Hi, welcome to Virtual CB1A. This is Miss Rena, and for today's video discussion, we are going to skip 1-2 because we already have videos uploaded in your classroom under cumulative review for those topics. So start tayo sa 1-3, collecting sample data. So, when using statistics in a study, planning is very important and it is essential to use an appropriate method for collecting the sample data. This section includes comments about various methods and sampling procedures. Of particular importance is the method using a simple random sample. We're going to discuss this later. We will make frequent use of this sampling method throughout the remainder of this book or this reference that we are going to use for this semester. As you read this section, remember this. Nasabi na natin to dun sa previous video na diniscuss natin. If sample data are not collected in an appropriate way, the data may be so utterly useless that no amount of statistical torturing can salvage them. So you have to be careful when collecting information or collecting your data for your analysis. Kasi baka masayang dahil may mga na-violate kayo at naging bias kayo on collecting your sample data. So let's start with part 1, the basics of design of experiments. The gold standard, randomization with placebo treatment groups is sometimes called the gold standard. So very popular to sa analysis for new drugs because it is so effective. So yung isang group, bibigyan siya ng placebo pill or treatment na wala talagang nakalagay na drug, and then the other group will be given the drug or the medicine. Tapos i-measure kung gaano ka-effective, kung may malaki bang difference between the two groups. So the following example describes how the gold standard was used in the largest health experiment ever conducted. So for example 1, this is the SAC vaccine experiment. So hindi ko na siya babasahin ng buo. This is to test the effectiveness of the SAC vaccine in preventing polio. So basically what they did was they randomly selected children and they placed it into two different groups. The first group were given a treatment consisting of the SAC vaccine injection, and the other group sila yung binigyan ng placebo treatment. So tinurukan sila ng placebo drug, wala talaga siyang content na medicine na anti-polio. So after this, among the children given the SAC vaccine, 33 lang yung nag-develop ng paralytic polio. And take note that both groups consisted of over 200,000 children. And then, the second group, yung placebo lang ang ibinigay, 115 sa kanila yung nag-develop ng paralytic polio. So, discuss natin yung example. So, example 1 describes an experiment because the subjects were given a treatment. But ethical, cost, time, and other considerations sometimes prohibit the use of an experiment. So, kapag sinabi nating experiment, you will be giving different treatments to different groups. Pwede kasing multiple treatments yan eh. I-discuss din natin siya later on kasi may iba't ibang design tayo na experiment. But in this specific example, dalawa lang yung group natin. One is controlled, yun yung may placebo. Tapos yung isa naman, yun yung experimental group, yun yung may treatment na ibinigay. Okay? So we would never want to conduct a driving, texting experiment in which we ask subjects to text while driving. Some of them could die. So sabi, na-discuss din natin siya dun sa previous na lesson natin. Sometimes, destructive ang census. So kapag sobrang marami yung ginamit mo for your sample, or kapag ginamit mo yung buong population for your sample, posible na may mga masira. Dito naman, sa example natin dito, if we are going to use a large number of sample, if we are going to tell the respondents to text while they drive and then see if this will increase their likelihood of um, encountering an accident, hindi siya mananagot tayo dito kasi may mababiolate tayo dito. Ethical, cost, time, and other considerations sometimes prohibit the use of this experiment. So ethically, we are liable for the safety of our respondents. Dapat hindi sila mapapahamak. So hindi natin to pwedeng i-conduct. Wala tayong magagawang experiment dito. But we can do an observation instead of an experiment. So it would be far better to observe past crash results to understand the effects of driving while texting. So see the following definitions. In an experiment, we apply some treatment and then proceed to observe its effects on the individual. The individuals in the experiments are called experimental units. So take note that by the word individuals, hindi naman laging tao yung ginagamit natin na experimental units. So hindi tayo limited with people as respondents. Meron din kasi tayong mga experimental units. For example, ang problema natin ay effectiveness ng isang fertilizer, then our experimental units will be plants. And then, the effectiveness of a vitamin for dogs. So, our experimental units will be, of course, dogs. So, yung word na individual dito, this doesn't pertain to humans always. In some cases, hindi sila tao. And they are often called subjects when they are people. So, and in an observational study, we observe and measure specific characteristics, but we don't attempt to modify the individuals being studied. So, sabi nga natin dito sa observational study, yung car crashes, yung nabanggit natin dito kanina, hindi tayo pwede mag-perform ng experiment because we will be liable for their safety. So, ethically, may mga mababiolate tayo. And instead of conducting an experiment, we can do an observational study. Dito, wala kang treatment na ibibigay sa mga respondents. Iyo-observe mo lang kung ano yung naging behavior nila in the past. So experiments are often better than observational studies because well-planned experiments typically reduce the chance of having the results affected by some variable that is not part of the study. A lurking variable is one that affects the variables included in the study, but it is not included in the study. So sometimes we also call this lurking variable intervening variable. Sila yung mga hindi naman talaga kasali dun sa study natin, pero possibly nakakaapekto sila. So for example, our study is all about um, the reading habits of high school students and their mm, grade in English. So, di ba dalawa lang yung variables natin? Reading habit nila, tapos yung grade nila sa English. Pero possibly, merong ibang mga variable na pwedeng makaapekto. Ano-ano yun. So, for example, the demographic profile. Pwedeng yung socio-economic status ng pamilya nila, yung income ng family nila, may effect din dun sa grade nila sa English. For example, they cannot provide money for projects. Kailangan dun sa subject, may projects ka na gagawin and wala silang cost. Although, yung reading habit nila ay maganda, pwedeng may ibang variable na makaapekto kung bakit mababa yung grade nila. So, I hope that was clear. Next, let's go to example number 2. Ice cream and drownings. Observational study. Observe past data to conclude that ice cream causes drownings based on data showing that increases in ice cream sales are associated with increases in drownings. The mistake is to miss the lurking variable of temperature and the failure to see that as the temperature increases, ice cream sales increase and drownings increase because more people swim. Ayan. So, ang intervening variable natin ay temperature increase. Yung ice cream sale, kaya sila tumataas kasi mainit. And then, pag mainit, marami yung nagsiswimming. Pag marami yung nagsiswimming, mataas yung likelihood na may malunod. Now, let's discuss the proposed experiment. Conduct an experiment with one group treated with ice cream while another group gets no ice cream. We could see that the rate of drowning victims is the same in both groups. So, ice cream consumption has no effect on drownings. Here, the experiment is clearly better than the observational study. Now, let's talk about the design of experiments. Very shallow lang yung magiging discussion natin dito kasi yung mga experimental designs natin ay later chapter pa natin siya i-discuss. So, good designs of experiments includes replication, binding, and randomization. Ano yung ibig sabihin ng replication? So, it is the repetition of an experiment on more than one individual. If you use very few individuals, pwede kang maka-encounter ng bias kasi kukonti yung ginamit mo. Good use of replication requires sample sizes that are large enough so that we can see effects of the treatment. In the SAC experiment in example 1, di ba over 200,000 per group? Sa treatment group, 200,000 plus, tapos dun sa placebo group, 201,000 plus. The experiment used sufficiently large sample sizes so the researchers could see that the SAC vaccine was effective. Now, let's talk about blinding. It's used when the subject doesn't know whether he or she is receiving a treatment or a placebo. Blinding is a way to get around the placebo effect. Kasi kapag alam nila that they are in the treatment group, sila yung makakatanggap ng medicine, possibly, i-claim nila, di ba nag-discuss tayo earlier, ng bias. Possibly magsinungaling sila dun sa totoong effect. Pwede nga ibigay nila sa'yo in order to please the people behind the study. Sasabihin nila, oo, effective. Magsisinungaling sila. Even though hindi naman talaga nila naramdaman yon. And then those in the placebo group, pagka-aware sila na wala naman talaga silang ini-intake na treatment, possibly magsinungaling din sila about the outcome. So, which occurs when an untreated subject reports an improvement in symptoms. The reported improvement in the placebo group may be real or imagined. The SAC experiment in example 1 was double-blind, which means that blinding occurred at two levels. The children being injected didn't know whether they were getting the SAC vaccine or a placebo. And number 2, the doctors who gave the injections and evaluated the results did not know either. So, double-blind siya. The respondents and those who administered, parehas walang alam kung placebo ba or treatment yung ibinigay nila. Codes were used so that the researchers could objectively evaluate the effectiveness of the SAC vaccine. Next, randomization is used when individuals are assigned to different groups through a process of random selection. As in the SAC vaccine experiment in example 1, the logic behind randomization is to use chance as a way to create two groups that are similar. The following definition refers to one common and effective way to collect sample that in a way that uses randomization. Define natin si simple random sample. A simple random sample of n subjects is selected in such a way that every possible sample of the same size n has the same chance of being chosen. A simple random sample is often called a random sample, but strictly speaking, a random sample has the weaker requirement that all members of the population have the same chance of being selected. That distinction is not so important in this text. Throughout, we will use various statistical procedures, and we often have a requirement that we have collected a simple random sample as defined above. So, we use randomization to avoid bias. Unlike careless or haphazard sampling, random sampling usually requires very careful planning and execution. Hindi siya katulad nung purposive sampling natin earlier at saka yung mga voluntary sampling. Wayne Barber of Kemekit, Kemekita Community College is quite correct when he tells his students that randomness needs help. So other sampling method. In addition to simple random sampling, here are other sampling methods commonly used for survey. So may figure ulit tayo, 1-3 illustrates these different sampling methods. So ito yung pinakauna natin, simple random sampling. A sample of n subjects is selected so that every sample of the same size n has the same chance of being selected. Okay? So kung ilalagay mo sila for example sa parang drawlats, halimbawa yung mga pangalan nyo, inilagay ko sa isang fishbowl. Tatlo lang kayo, di ba? So, Gillard has the same chance of being selected as Valerie and Joshua. If I put two names, two papers, wherein ang nakasulat ay dalawang Gillard, tapos tigisa lang si Valerie tsaka si Joshua, hindi na yun simple random sampling. Why? Kasi mas mataas na yung chance or likelihood ni Joshua to be selected than the other two. So if I put two papers for Gillard, if I want to satisfy uh, the requirements for simple random sampling, I should put two papers for Valerie and for Joshua as well. Now, let's talk about systematic sampling. Ito madali to kasi you have to select every Kate subject. For example, you are given a list. Di ba na-discuss natin earlier yung sampling frame? Pwedeng kumuha ka ng list from a very reliable source. For example, lagay tayo dito ng mga names. Name, si student 1. Ito si student 2, si student 3, 4, 5, 6, 7, 8, 9, 10. And then our K, for example, is 3. Every third student will be selected. For example, I decided to start at 4. So 4, 1, 1, 2, 3. Si 7, kasali rin siya. And then 1, 2, 3. Si 10 kasali rin siya. I need 4 respondents. After 10, 1, 2, 3. Ayan. So, I will be using student 3, student 4, student 7, and student 10. This is also called skipping sampling. So, kasi nag-i-skip tayo. Depende dun sa number K. Next, we have convenience sampling. Ito medyo biased to. Bakit? Use data that are very easy to get. So, kung sino lang yung available, sila lang yung tatanungin mo. For example, yung sa mga grocery, supermarket, yung mga nagpapa-free taste, they will ask you after if you enjoyed their product or not. 'Di ba? Pero, kaya lang sila dun pinwesto kasi nandun yung possible na market nila. And also, for example, magpapa-survey ka dito sa Paite. Pumesto ka dun sa isang mataong lugar. Kasi alam mo, dun ka makakakuha ng mga possible na respondents, but you didn't have a systematic list. O kaya, in-approach mo yung isang tao kasi alam mo that they will never refuse to answer your questionnaire. So, convenience sampling yon. If you purposively chose them because you know that you will get you will get a response or you will get a datum out of them. Ito medyo popular to. Stratified sample. So you are going to subdivide population into strata or groups with the same characteristics, then randomly sample within those strata. Ito unbiased to. Tapos, ang maganda dito, um, naka-separate yung group. So, meron kang even na proportion for each group. For example, meron tayo dito 2, 4, 6, 8, 10, 12, 14, 16. So, 16 sila. Tapos, equal yung number ng men and women. There is a chance that if you use simple random sampling, pwedeng ang makuha mo, 5 lalaki, tapos isang babae lang. Hindi proportion to the whole division ng population. So, yung mga defining characteristic nila, ililista mo yon and then you are going to separate them. For example, gagawa tayo ng survey dito sa Paite. Si Paite, meron siyang 9 na barangay. Tama? So, paano kung nag-simple random sampling tayo, tapos naipon, walang naging representative si Barangay 9? Medyo magiging bias na yung result natin kasi merong isang barangay na walang representative. So, for us to avoid such instances or such cases, we can opt with stratified sampling. So, gawa tayo ng strata. Uh, I-divide natin into 9 barangay. Tapos, tingnan natin kung gaano karami yung per barangay. And then, the number of samples that you will take per barangay should be proportional to their population. So, kung pinakamarami si Barangay 1, dapat siya rin yung pinakamalaki yung sample na representative. Next, si Barangay 2, siya yung pinakamaliit dun sa population. So, the sample that will be taken out of Barangay 2, dapat siya rin yung pinakamaliit na representative. Later on, we are going to discuss this and give a better example. Itong cluster sample, okay din naman siya, pero ang hindi maganda dito, you are going to partition the population in clusters or groups. Parang katulad ni stratified. But, in cluster sampling, there is a chance that one of your groups will have no representative at all. Kasi kapag kinluster mo siya, partition of the population in clusters or groups, then randomly select some clusters, then select all members of the selected clusters. Barangay 1, Barangay 2, Barangay 3, 4, 5, 6, 7, 8, 9. For example, cluster sampling tayo. Tapos ang nabunot natin, Barangay 1, 2, 4, 5. So, yung 4 lang. Sila lang yung gagamitin mo for your study. Walang representative yung mga barangay na hindi nabunot. Pero, yung 4 na barangay na nabunot, um, lahat ng contained nila sa population nila kasali dun sa study mo. So, para ka magse-census out of those clusters that was selected. Dito, pwede kang maka-encounter ng bias kasi may mga grupo na hindi mo isasali at all. So, para siyang stratified, pero hindi. So, yun yung similarity ng stratified and cluster. Both of them are subdivided into groups. But for stratified, please take note that every group will give its own set of respondents. There will be representative for every strata. But for cluster sample, hindi. May mga grupo na hindi kasali. Ayan. May better definition tayo dito sa baba. In systematic sampling, we select some starting point and then select every kit, such as every 50th element in the population. So, katulad nito example natin dito kanina, my starting point is 4. And then every third respondent from 4 will be included in the study. That's why we ended up with student 4, of course. This is our starting point. Followed by student 7. Next is student 10. And then, since ubus na yung yung bilang natin, babalik na tayo dun sa unang-una. So, 1, 2, 3. Si student number 3 naman. O, tuloy tayo. With convenience sampling, we simply use data that are very easy to get. Next, stratified sampling. We subdivide the population into at least two different subgroups or strata so that the subjects within the same subgroups share the same characteristics, such as gender. Then we draw a sample from each subgroup or stratum. And in cluster sampling, we first divide the population area into sections or clusters. Then we randomly select some of those clusters and choose all the members from